Here's a lesson on a revision or a quick resume of the basic circuits. Okay, let me present you with a simple circuit. We have a cell and a resistor, and it could be any component in there. That could be resistor or a light bulb, anything which uses up electrical energy. And in there as well we're going to place an ammeter. Fantastic. Now, our reference point of all circuits is going to be a coulomb, and a coulomb is called a group. Well, it's a term for a group of electrons, and those electrons fly around the circuit, moving from the positive into the negative side, and they go to the component in your circuit. They give up the energy because they're carrying energy around the circuit, and they travel back empty, ready to be recharged and pumped back around the circuit again. Now that is, so this is a group of electrons, and it's called 1 coulomb. Okay, why bother having this group of electrons rather than one? Well, the electron's so small in size and charge that your sums would start adding up to having, 10 to the 20 electrons. So therefore we make the sums much more easily, and we call it 1 coulomb. Okay, the first things first, what does this meter do? Well, this is known as an ammeter, and it measures the current. Okay, it's useful to get a definition, because what I want you to be able to do is understand how this circuit works from first principles rather than just applying equations to every situation you find. So let's just say, for example, 1 amp will equal 1 coulomb per second is running around this circuit. That means if this were 1 amp, it means the battery would be pumping out 1 coulomb every second. 1 coulomb would be moving around and entering into this component every second. 1 coulomb would be coming out per second, etc., etc. Just like train cars bumping along shoulder to shoulder around a track. If this were 2 amps, then it would be 2 coulombs going around the circuit every second. So it gives you a measure, if you like, of how fast the electrical charge is flowing around the circuit. Okay, now if I were to ask you a very simple question then, and I said this is flowing at 2 amps, how many coulombs will flow around my circuit in 10 seconds, then intuitively, I hope you'd all understand that in 10 seconds, then, if 2 are coming out of the battery per second, I need multiply by how many seconds I've got to give me how many coulombs. And the symbol for coulombs is C. Fantastic. If this were, let's try, what about in 1 minute? Now if you notice here, I've changed the units of time. So what's going to happen now? Well, it's going to be still 2 lots are coming out of the battery per second. And now how many seconds have I got? I've got 60 seconds. So be careful there with when you're changing minutes into seconds. That gives me 120 coulombs. Excellent. Okay then, so what we've sort of done intuitively is that we've used in here an equation, and in order to get how many coulombs, in other words, okay, what we've done is we've found out the current, and the symbol for current is I, and multiplied it by T. Okay, so maybe I should put up here current. The letter for current is I. It is measured in amps. And when I say how many coulombs, another word for that is the charge. So how many coulombs is the same thing as calling the charge of the circuit. So you need to really burn that into your brains there. How many coulombs means charge. People often say to you in a question, what's the charge? And people often go blank, not quite knowing what it means. But if you understand that charge is how many coulombs, that circuit must make much more sense to you. Okay, excellent. Now let's look at the other component of a circuit, we have, the next component is the voltage. Let's imagine I have 3 volts in there. What exactly do 3 volts mean? Well, 3 volts is telling you how much energy each of the coulombs takes. It's a very simple idea in that if it's 3 volts, then every coulomb will take 3 joules of energy around the circuit with them. If it was 6 volts, they would take 6 joules. 1 volt, they would take 1 joule. So this is the number of, so 3 volts equals the number of 3 joules per coulomb. In actual fact, everything is referenced to the coulomb. Current talks about how fast they go around, and voltage talks about how much energy each one carries. Okay, excellent. So, if we now want to talk about how much energy is coming out of this battery per second and how much energy is flowing around the circuit per second, then we're going to have to bear in mind 2 things. One is, we need to work out how fast or how many coulombs are coming out of the battery per second, and then we need to know how many joules each coulomb takes. So in this instance, if I talked about how much energy, the energy per second, then in this case I'd say to myself, okay, I know that each coulomb will take 3 joules, but I know that I've got 2 coulombs coming out of the battery per second, giving me 6 joules every second. And there is another word for what energy per second is, and that is called power. Power is measured in watts. And essentially what I've done, but you have done this intuitively, but what I have done is I have taken the voltage and multiplied it by the current. And that is our expression for power, measured in volts and measured in amps. So, power is current times voltage. Our second really important equation. I've just drawn there energy per second. Superb. So we've got 2 equations running there, but both of which you hopefully would have worked out intuitively, as I said before. Superb. Okay, let's try the next one. If we know that the energy per second is the power, then we might, in some instances, have to work out what's the total energy has the battery used in a certain time. So how much energy is poured out of this battery, say in 10 seconds or 1 minute. So how are we going to go about and do that? Well, let's say we know how much energy per second is coming out of the battery. Therefore, what's the total energy? Let's say used in 10 seconds. Well then, we know how much is used per second, and you merely multiply it by the 10 seconds to give you the total energy. In this case, 60 joules would have been used. What about in 1 minute? Well, in this case, once again, being careful that we convert those minutes into seconds, we have 6 joules being used per second, and multiply that by 1 minute, 60 seconds, gives us 360 joules. So what hopefully what you're doing in your brains is to work out the energy. You've taken the power and multiplied it by the time. Okay, but there's another way to be able to do this, because if you can see here, we've got an expression for power anyway, so we could miss out the step of calculating the power and just jump straight into working out the energy by substituting these values straight into power. So therefore we could say energy is the same as, if we substitute I times V into power, I times V times T. And you could find out exactly the same values as before, whichever way you use. So let's look at this example again. Let's look at the 1 minute example again. And let's just make sure we are familiar that we're using 3 volts and 2 amps are being used. And it's happening for 60 seconds. So therefore, the energy being used is going to be the current times the voltage times the time, which means 2 amps by 3 volts by 60 seconds, and that comes out to be 360 joules, just like before. Okay, brilliant. So essentially we have these equations down the side. We need to know how to work out the charge, but you can do that by the definition of the amp. We need to know how much power, energy per second, is being used up by a circuit, but you can do that by understanding what the voltage and the current is in a circuit, and the energy is merely a multiplication of that power by the time. Excellent. Okay then, let's try a few simple questions for this one to start with. Okay then, let's imagine I've got a household item. I've got a kettle. Here's an example. Okay. I've got a kettle. And it uses mains electricity of 230 volts. That's what happened. That's what comes out of the mains all the time. And it draws a current of 10 amps, very large. That's a significant current. And it runs for 50 seconds. Okay, so to boil a kettle, say a half full kettle, it's going to take 50 seconds drawing 10 amps. Okay, so first of all, what power is being used? And secondly, what energy, total energy, is being used? Now, if you think you can solve this question already, hit pause, give it a go, and then you can look over the solution, which I'm going to present straight away. Okay, here we go. The answers to part A. What's the power? Well, the power, essentially what you know from this information is that 10 coulombs are being pumped out of the mains every second, and each one is taking 230 joules. Or in other words, the current multiplied by the voltage. And that's going to give us 2,300, and if you remember, the unit for power is watts. Excellent. Part B. What's the energy being used? Well, if we know that's what's being used up, 2,300 joules per second, then if it's running for 50 seconds, then we should be able to work out the answer, because we can multiply the power by the time. So we have the power of 2,300 by 50, giving us 115,000 joules, which is quite significant. You might prefer to write, when the numbers get that big, to write it in standard form, 1.15 times 10 to the 5 joules, which is, it's neater, it's cleaner. 1, 2, 3, 4, 5. Superb. Okay then, let's give another example and just see how we get on. This is the last example. Okay, we have a light bulb. Which runs for 5 minutes. That should be a 5. It uses mains electricity, which is 230 volts, and draws, let's go, 3.8 amps. much less. So A would be, what's the power used? And B, what's the energy? Now once again, if you think you know how to do it, pause the video here, give it a go, otherwise I'm going to run through the answers straight away. Okay, A, the power. Well, once again, we know that we're running at 3.8 coulombs are coming out of the battery per second, and each one is going to take with it 230 joules of energy with it. So therefore, our power is going to be, this is quite a large power, 874 watts. In actual fact, just thinking about that light bulb is incredibly bright. That's more like a stadium spotlight. So apologies for getting those numbers slightly wrong, but nonetheless, let's carry on and see. Let's follow through the numbers consistently. Okay, so for B, it asks, what's the energy used? Well, we know the power now, the energy per second, so we merely multiply that by the number of seconds. So we have 874 multiplied by 5 minutes, which of course is 300 seconds. And that gives us 26200 joules. A significant number of joules. Okay, I hope that makes sense. Checking out.